that what is chemical bonding, why the atoms, they have an urge to go for some relationship in the form of bond. We have found that whenever the bond formation takes place, in this process, individual atom attains stability, and by lowering their potential energy, and by that they try to achieve the octet configuration. Okay. So we have found that this octet configuration can be achieved by two ways: either by loss or gain of electrons. In this process, the atoms, they convert themselves into cations and anions, and each of them attain octet. And by the formation of these ions, they come closer to each other through electrostatic forces of attraction, and a type of relationship or interaction is formed, and that we call as ionic bonding or electrovalent bonds. Second method we have found, it can be done by the sharing of electrons. In the process of sharing electrons, all the atoms attain octet configurations, and in that process, there may be a pair of electrons equally shared by both the atoms, or it may be more than one pair. If only one pair is there, then they form a single bond between them. If there are two pairs, then there will be double bond between them. And in case of nitrogen, we have found that three pairs are there, by which between two nitrogen atoms, there are three bonds. Okay, and we call them as a covalent bond. And the third option that you have found, it may be that one of the atom does not have enough hydrogen to share. In that case, the other atom gives both the electrons, and after the donation of both the electrons, then they equally share them. And so such type of the bond is called coordinate covalent bonds. Okay. So now let us write the definition of electrovalent bond or ionic bond. Please write down. I'm just telling you. Electrovalent bond or ionic bond. Right. The electrostatic force, of attraction which holds the oppositely charged ions together is known as.
Sir, can you repeat?
The electrostatic force of attraction which holds the oppositely charged ions together is known as ionic bond or electrovalent bonds. Now, question is that what type of atoms will form ionic bond or electrovalent bond? Let us know a little bit See, everything we should not take into granted as a heavenly blessings. Heavenly blessings you cannot explain. No, these are not miracles. So we should know. Conditions for forming electrovalent or ionic bond. Conditions for forming electrovalent. Let me locate this portion which reflects. Electrovalent or ionic. The one. Number of valence electron means number of electrons in the outermost shell. Okay. It is one of the atom should have one. Okay. What type of atoms you should have one in valence electrons? You know it, like lithium, sodium, potassium, etc. You should know. Two, it should be what? Calcium, barium, magnesium, barium, etc. Or three, there are very few. Aluminium, iron, etc. Valency electrons. While the other atoms should have, while the other atom should have five. Where do you have 5 electrons in the valence shell? Group 15. Okay, so it can be nitrogen, phosphorus, arsenic, etc. 6. Where do you have? Group 16. Oxygen, sulfur, etc. Or 7. Which are these? Halogen. Fluorine, chlorine, bromine, iodine, etc. Okay? Valence. See? Means what? In this case, sodium will lose one electron, it will come to chlorine. See, moment sodium lose one electron, it becomes octet, and this one electron will come here. 7 plus 1 is 8. 2 plus 6 equal to 8. 3 plus 5 equal to 8. Second, then why should they lose? And why they should gain? Okay? Then, in that case, difference in electronegativity. Difference in electronegativity. If there is a large difference of electronegativity between two combining atoms, only when there will be formation of electrovalent bond. Please remember, electrovalent bond or ionic bonds are formed between highly electropositive elements and highly electronegative elements. I told you, no, if you learn periodic table, then you half of the chemistry you have learned. The formation of electrovalent bond will be easier if the difference in electronegativity, if the difference in electronegativity of between two
So what's that of the easier?
up Shifang. Bolo. Yes. Hello. See, difference in electronegativity. Okay. The formation of electrovalent bond will be easier if the difference in electronegativity between two combining atoms of about 2. About 2. Is necessary for the formation of an electrovalent bond. Electrovalent bond. So these are the two conditions. Okay, now one more I'll write. Third condition. Third condition, that in the formation of an electrovalent bond, of an electrovalent bond, there must be decrease in potential energy. That is, they should be friendly with each other, not quarreling. So, how do you know decrease in potential energy? That is, they should release energy. They should release energy must be released. These are the three conditions.
Sir,
Yes.
sir, can you explain that third point again?
When sodium and don't write. Sodium and chlorine has come together to form a bond. Now see, it is an atom, this is an atom. Sodium has 2H1 configuration, it is having 2H7. So in that case, individually they are not stable. Okay, so they want to attain stability. How it is possible then? In that case, what will happen? One of the electron of the sodium will, I'm just writing the valence electron. Okay. Here. 6 plus 1, 7. Sodium has 1 extra. So if it goes, then what will happen? After that, you see here, you have 2, 8. This is not there. So 8. After accepting, what do you get here? Okay, right now. You will get here now Na plus. It is 2, 8. Cl minus. So in that case, it is 2, 8, 8. See, my question is that sodium has lost electron and chloride has taken electron. All right, very nice. But after that, when they come close to each other, their attraction should be very strong. That is, they should like each other. In that case, they are going to form a stable ionic compound or electrovalent compound. If they do not like each other, in that case, what will happen? The compound will not be stable. Everywhere we cannot explain by the theory. But ultimately, the question is that everything in the nature, they want to be stable. In that case, any stable relationship do not have any strain. Do not have any strain. In that process, to release the strain, the energy is released. See, if you, in your classroom, you may have many students. You are saying hi and hello to everyone, but with everyone, your relationship is not strong. Okay? If anyone is close to you, in that case, what you find? You do not keep any jealousy and anger between this relationship. So you forsake it. When you we forsake our anger and jealousy, in that case, that crystallizes into a good relationship. Because of that habitat, in the formation of an electrovalent bond, there must be decrease in potential energy. That is, you should not have mutual hatred. They should like each other. So in that case, the energy must be released. See, when you get angry, why do you shout or cry? Why? See, I told you, no, as the atom behaves, you also behave. Moment you shout or cry or quarrel, all the energy is being released. Again, you come down to a normal state. Clear? I'm just tell you some properties of the ionic compound, but please read from the book. These are not hard. Okay? Because this chapter is very big, and if I take so detail, I will not be able to cover other chapters. Class 11, most of the chapters are very, very important. And my one request I have for you, please remember, all class 11 chapters are very fundamental chapters, and these are extremely important for your entrance exam. Around 50, in class 12, more chapters are there, but in entrance exam, maximum question comes from class 11, because this is the fundamental part of the chemistry. Okay. So, right, general properties of ionic molecules or ionic molecules. General, please read from the book. General, that you already studied in school also, in 9 or 10. General properties of ionic . Okay. 1. These are crystalline in nature. All of you have seen the crystals. Okay, they are crystalline in nature. Right. This one I will explain to you when we will go to class 11. What is crystalline? In any compound, the molecules can be arranged in two different ways. They say it is very, very systematic. Don't draw. See there. Did it not take a geometric shape? When they are systematically arranged with regular spacing, in that case, the shape of the molecule takes a shape of a geometric figure. Okay, so these type of substances are called crystals. But if they are randomly arranged, they will not have any fixed shape. Those substances we either call amorphous state or you call it powder. So, ionic compounds, these are crystalline in nature. Second, they have high melting and boiling points. Okay, very nice. Let me tell you. Say, this is an ice cube. See here, this is an ice cube. So if you keep an ice cube on plate, does it move by itself? It cannot move by itself. But after some time when the ice melts, okay, say in the cup, this is a plate, you'll find this is a water state. If you just raise this one, you'll find the water will go and will spill over. That is, water molecules can move. But this ice and the liquid water both are being made by this molecule. Then how does the property changes? Why they can move? See, in case of the crystal, the particles are very, very close to each other. Very, very close to each other. So they do not have any space to move. But in liquid, you'll find the space between them is large, so that they can move. It is just like that. You have entered a very extremely crowded place. In that case, if you want to come out from there, it's very, very difficult for you to come. In that case, either you have to request the people repeatedly or you have to push some people to make some space for you. But suppose you are working, especially in this pandemic period, very few people are there on the street. You can find you have the liberty to move in any direction. There will not be an obstruction for you because the gap between the next people to you is large. Clear? Now, why ionic compounds have very high melting point and boiling point? Because ionic, see here, these ionic compounds, in that case, ions are very, very close to each other. Why? Because of the strong attraction between the oppositely charged ions, which we call it electrostatic force of attraction. Now, if you want to create a gap between them, you have to spend a lot of energy to separate them. And where from the energy will come? The energy will come in the process of the heat that you have supplied. Due to that, we'll find the ionic compounds have very high melting point and boiling points. Please read from the book. Yeah. Third, these are very hard, yet brittle. See here, seems to be just opposite. Any hard substance we know it is difficult to break. But we find ionic substances are very hard yet brittle. Why it is like this? See here, I'm just telling you. See, this is plus minus, plus minus. Okay, minus plus, minus plus, plus minus. Try to understand. If you don't understand, tell me. See, these ions has come very, very close to each other. They are very compact. Okay? So anything which is very compact, it becomes hard. But if it is so hard, then why do you say you can break it easily? Please remember here, it is not linked to each other. They are only sitting in that place. They do not have any relationship except why they are sitting very close to each other, because they want to neutralize their charges. Other than that, they do not have any individual relationship. They do not have any link. It's just like that, say, in your house, for some construction work, you have bought some bricks. So what do? Bricks, so you pile up in one place, is it not? So this is the bricks. Bricks you have piled up in one. Okay? So this is the next layer of bricks. This is the next layer of bricks. Okay? So this type of several layers are there. Now see, on this brick, if you wish, you can sit. On this brick, if you wish, you can walk. By walking or sitting on the bricks, does it break? No, because the weight is being taken by in all the bricks. But if you push it, you'll find one brick after another brick will fall. Why? Because you did not put any cement in between them. All right, if you push, layer after layer also will fall. So similarly, if you push, this layer will go out. Then if you push, this layer will go out, because they are not interconnected. They are only sitting side by side. Similarly, these bricks, if you push, it will go on falling down. But once you put cement in between them, then you will find the bricks will not separate from each other. Why? Because you have established a relationship between them. Similarly, these ions do not have any, they are not interlinked with other. They are only sitting there, just like to neutralize their charges. Just like that, in your classroom, 2, 3, or 4 of you are sitting in one bench. In a classroom, you have very friendly relationship. Okay, but mind it, after the school is over, all of you go to your individual houses. All right? Because you do not have any family relationship or blood relationship with them. Because of that, they are very high. Why they are very hard? Why? Because they are extremely closely packed. Okay? And why they are brittle? Because they are not interlinked with each other. If you push, each and every layer of these ions will can be separated. Okay. Now, solubility. Solubility. Okay. Ionic compounds are soluble in polar solvents like water. Okay. Ionic compounds are soluble in polar solvents like water. There's a famous saying is there. We call like dissolves like. Like in English, we have a saying: the birds of same feather flock together. Is it not? So, if a compound is ionic or polar, it will like to stay with another compound which is of the same nature. So all ionic substances are polar in nature, so they will be soluble in water. But you cannot dissolve common salt in petrol because petrol is a hydrocarbon which is non-polar in nature, so it is not soluble. Please remember. This page, I think I'll take photo and send it to you. Electrical conductivity. This also you know it. What should I write here now? Ionic compounds don't get confused, do not conduct electricity in solid state. See, ionic compounds conduct electricity only through ions. So in that case, what will happen? The ions have to move. In a solid state, can the ions move? They cannot move because they are very, very tightly packed. So because of that, I have written ionic compounds do not conduct electricity in solid state, but conduct either in molten. Molten state means what? That the ions can now move either in molten state or in aqueous solution. That is in, you made a solution in water. Okay, solid sodium chloride crystal do not conduct electricity. But if you dissolve it in water or if you melt it, then that sodium chloride can conduct electricity. Right.
Sir, done. Sir, done.
Sir, done.
Okay. Finish now. See here, I want to tell you something. I don't know whether you have heard about it or not. It's called, see, if it is a question of neutralization of charge, if I write here plus and minus, total is equal to what? 0 or not? See here. Now if I write plus and minus, it is also equal to 0. If I write minus plus, that is also equal to 0. Then if I write minus plus, don't write, that is also equal to 0. Why did I write like this? Any chemical compound here, whether it is ionic or covalent, its total electrical charge is 0. All right. So when I take an ionic compound like sodium chloride, generally we have a convention of writing Na plus Cl minus. This is only convention. Clear? Now this carries on positive charge and this carries on a negative charge. But if I write here my Cl minus and Na plus, that is also correct. If I write like this, Na plus and Cl minus, that is also correct. If it is Cl minus and Na plus, that is also correct. Then why do you write like this? When there's so many options are there for writing a structure of a formula of a molecule, it may lead to confusion to the people. So we give a ruling. No, you cannot do like this. You have to write like this. You'll find in your house also. If three, four of you are there, and brother and sister are there in your house, in that case, with anything you'll find there may be a quarrel. Then you'll find either, in that case, generally the mother only comes and interferes. She will tell, no, you cannot do like this, you have to do like that. There is no logic. In many cases, logics are not there. Okay? But you have to obey. So this type of thing you will find maximum in the religious cases. Many religious practice, whatever we do, these have no meaning at all. It is useless, illogical. You may think that I'm talking about religion. No. This has no meaning. But still you do. Why? It is being arbitrarily decided. So we also have decided Na plus Cl minus. But in a science, we have to tell that there is no fixed isomerism. So isomerism is that, what is the meaning of isomerism? It is their orientation in the place, in the space. Okay? So in that case, we'll write here the term. I do not know, in your textbook it is not being mentioned, but it's very funny. It should have been there. We call it. What is the number? I think 5, no? 5 or 4?
Now we have
Sir,
to
6.
continue with number 6.
6.
Very good. We'll write now here space isomerism. It is if I go for a 3-dimensional geometry, in that case you will find ionic compounds do not have any fixed space isomerism. All right. But when you go to organic molecules, we are going to discuss maybe after 1.5 months, I'll go to organic, you'll find you cannot write anything like this because there is a fixed geometry there in organic molecules. So we'll write here ionic compounds do not show space isomerism. Do not show space isomerism. All right. Now, all right. Now we'll go to covalent bond. These are very easy. You could read at home also. Anyway, I also have a satisfaction. I can tell that I have taught you. Otherwise, you will say, sir did not tell. Covalent bond. What is the definition of covalent bond? The bond formed between two atoms of same or different element by mutual sharing of electrons between them. is called a covalent bond or covalent linkage.
Sir, done.
Very good. Nice. Now, what should the condition? Condition is that atoms with small difference of electronegativity form covalent bonds. The electronegative difference will be less. See, I'm giving you a rough idea. In our periodic table, this side you have hydrogen, and here you have helium. Then here you have lithium, then you have beryllium, then you have boron, then you have carbon, then you have nitrogen, then you have oxygen, then we have fluorine, and then you have neon. So this one, though, you know, these people are, they do not like to interact with others. So we call them as noble. Noble means what? They don't find a relationship with us. All right. Now see here. These are highly electropositive and these are highly electronegative. When they come near to each other, highly electronegative element, I told you what is the property of electronegativity? They have a tendency to pull electrons. So in this case, you will find this between lithium and fluorine. Okay? The relationship, what type of compound they will form? They will form ionic compound because there is a large difference of electronegativity between them. Fluorine is the highest electronegative element in the electronegativity scale. Its value is 4. Electronegativity scale does not have any unit. Lithium is less than 1. Difference is almost 3. Now see here. When you come from left to right, electronegativity increases. Okay, now see here. From here again, if you go, electronegativity increases. So the difference between these two is less than that of 2. Difference between these two is less than that of 2. In that case, you will find that carbon and hydrogen form covalent bond. Same thing that carbon and fluorine also forms covalent bond. So difference between them is less. So highly electropositive element do not form ionic compounds or highly electronegative elements. But if you have taken the element from the middle of the periodic table or at the bottom of the periodic table, in that case, you'll find they are going to form covalent molecules. Now, what are the characteristics or property? They will be almost opposite of the ionic compound. Characteristics of covalent.
Sir,
Yes.
sir, for covalent bond, there's only one condition, sir.
One condition.
Okay, sir. Thank you, sir.
Because of the habitat near condition. So first of all is that in case of ionic compound, what is the physical state? Physical state was it is a crystalline in nature. So in this case, physical state is what? They exist in gaseous, liquid, and solid state. See, please remember what is the difference between gaseous, liquid, and solid state. In gaseous states, molecules are very far. They remain very far away from each other. Then liquid, the gap is little less. And in the solid, it is like this. Okay? So in that case, you'll find depends upon the attraction they have for each other. If the attraction is minimum, they'll exist in the form of gases, in the form just like in the form of hydrogen, oxygen, nitrogen, carbon dioxide, methane, ethane. They all have very, very less attraction for the other molecules. So they exist in gases. They exist in liquid form, like water, like petrol, like benzene. Their attractions, as the size of the molecules increases, the attraction little increases. So in that case, you'll find they exist in liquid. But if it is very, very big and bulky, then their attractions become very high. In that case, they become more compact and they are solid in state. But even if they are solid there, their melting point is low because their attractions among them is not very high. Okay, not like the ionic compounds. So they are low melting and Beryllium. So again, low melting and boiling points. These compounds have weak intermolecular forces of attraction. Okay, and hence they have low boiling and melting points.
Sir, done.
Okay. Then you write third. Solubility. Please remember, these are not polar. Solubility. These compounds are not polar. Hence, these are soluble in non-polar organic solvents, but not in water. They are not soluble in water. Because of that, when you pour petrol in water, you find petrol floats in water. It doesn't go into solution.
Sir, done.
So now, fourth, non-conductors. They do not conduct electricity. These do not conduct electricity in any of its physical state, that is in gaseous, liquid, or in solid state. Okay. See, covalent compounds have fixed geometry. So right now here, 5. Space isomerism. Covalent compounds have fixed geometry and hence so space isomerism. I'll give you one example that you have done in school also. This example is not difficult. Okay. A little bit organic chemistry you have done in school. I know. See here. I have taken a compound, this. Okay. And I have taken a compound, this. Same compound. But see here. Their geometries are different. Geometries are different and its physical properties are also different. This is called space isomerism. This is called cis and this structure is called trans. Cis. Okay. So the name of this molecule is cis due to E. After a few days you will also be able to link. So don't get scared. Trans due to
Sir, done.
So now we'll go for the third category. It's called coordinate bond. Coordinate that you know right now. A covalent bond in which both the electrons of the shared pair are contributed by one of the two atoms is known as coordinate or dative bond. Okay. Example is what? Say I taken this A. C is having octet, and this B, it does not have any. It has 6 electrons. Means what? Huh? This is electron deficient. So it will give like this. So what will happen now? I'll write now here. A, B. See here, it is these electrons are not given by B. I did not write anything here. So generally, this type of bond earlier used to write like this. A, but we do not write this like this. We write like this. This is the earlier concept. Earlier concept. Okay. Properties of the coordinate bond is same as that of the covalent bond. All right. So in that case, I am not going to repeat it. All right. The properties are same.
Sir,
Yes.
sir, in this case, compound A will always be a noble gas because it has stable electronic
No,
configuration.
no, not like this. Not like this. Sorry, dear. Sorry. Noble gas नहीं होगा. Noble gas इधर reaction ही नहीं करता है. Okay, I'll do it for you. C H H H. ठीक है. ऐसा नहीं. I'll write it. Please excuse me for my bad drawing. So this is C. These are perfect covalent. Hydrogen and nitrogen contributes. See, nitrogen has 5 electrons outermost shell. 1, 2, 3, and that's 2. So this is not being utilized. This is not noble gas. All right. Now, this is poor hydrogen. This fellow does not have any electron at all. Okay, it's H plus. It is H plus. What is going to happen? They will combine to give you what? See. See here. See all the pocket money that you have, where from it comes? Hmm? Where from you get pocket money? Prime Minister sends you.
Father.
Ah, yes. But once the money goes to your pocket, do you call it mother's money? Huh?
No, sir.
Hello? Ah,
No, sir.
No, sir.
that is coordinate bond. Okay? So your mother is, should you call, yeah, you can see your mother is great, but do you call your mother noble? Is she an inert substance? Huh?
No, sir.
Ah, yes. Properties of noble gases are same as the property of the covalent bond. Hmm? Once the formation of the covalent bond takes place, they will behave like a ordinary covalent bond. So in that case, what will happen? You will find physical state. It may be gas, liquid, or solid. Its melting point and boiling points are lower. Its coordinate bonds are not soluble in water. Okay. Solubility, I told you. Conductivity, they do not conduct electricity. Yes, they also show isomerism. Okay, all these things that we have done till now, all these theories and this ultimately the definitions that we have done, these are all based on, all the structures are based on Lewis octet theory. But it is not that all the molecules are following the Lewis octet theory. So let us write exceptions to the Lewis. Hold right hand now. Exceptions to the octet rule. There are very stable molecules are there which do not follow the octet rule. First, let us go for hydrogen molecule. Hydrogen molecule. See, in hydrogen molecule, you do not get octet, you get doublet. See here. Hydrogen is a highly stable compound, but it does not follow Lewis octet rule because it does not have any electron. So they will combine with each other to share only one pair of electron. If you add it, it becomes 2. So we call it is a doublet. In case of hydrogen, it is doublet. Okay. Second, we go for incomplete octet. Okay. So I am giving you one example. Say I have taken here lithium chloride. See, lithium has how many? What is the electronic configuration? Lithium 1s2, 2s1. What is the configuration of chlorine? 1s2, 2s2. Okay, let me write here chlorine. Let me not confuse you. Chlorine 1s2, 2s2, 2p5. How does this compound form? In Lewis octet theory, you are only supposed to write the valence electron. See here. This lithium has 1 lithium and chlorine has 7. So 1, 2, 3, 4, 5, 6, 7. See, this chlorine is having 8 electrons. Is it not? 8. And lithium is having how many? 2. So in that case, it is having incomplete octet. Incomplete octet. Okay, this is one example. Let me go for second example of beryllium chloride. Beryllium So beryllium is 4. It is 1s2, 2s2. And chlorine is 70. So it is 1s2, 2s2, 2p6, 3s2, 3p5. Okay, so I'm drawing the beryllium structure here. You can draw it here because I have to bend pen, so I cannot bend forward. Okay, so now I'll write here now. This is beryllium. This is one chlorine. This is another. Here, beryllium has 2 electrons, 1 and 2. Chlorine has 7 electrons out by valence shell. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. See here, this is 8, this is 8, but this is what? 2 plus 2, 4. So this is also having incomplete octet. Okay, draw.
So done.
Let us wait for two more minutes. I don't know what others. Others they
So
don't.
done.
Only done. Huh? All ladies. What about that one or two male person are there in this group?
Sir, done.
Very good. Then I'm going. Now we'll go for BF3. See. So boron is 5. 1s2, 2s2, okay. 2p1. Fluorine is 9. 1s2, 2s2, 2p. 5. So this is the valence electron. This is the valence. See here now. Boron. Fluorine. Fluorine. See here. Boron has 3 electrons. So it is given to each of the fluorine. Fluorine has 7 electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. Now see here. Each fluorine is having 8, 8, 8. But how many? 6. So it is incomplete octet. All right. Now I'll do one more for AlCl3. Okay. First you finish, then I'll write for AlCl3 because these are important for your exam. They'll ask you to draw.
So finished.
Sir, done.
আচ্ছা ভালো কথা AlCl. Okay. Aluminium 30. Fluorine 70. So it is 1s2, 2s2, 2p6. Then 3s2, 3p1. See, this is the valence shell now. And it is then 3s2, 3p5. So this is the valence shell. So what I'll do now? Aluminium chlorine, chlorine, and see. So AlCl3 is also incomplete octet species. So we have done hydrogen molecule, then we have done the incomplete. These are the example of incomplete octet. Okay. So this is the example of what? Incomplete octet. Now we'll do. Can I have it?
Yes, sir.
Now we'll go for third. It's called expanded. Sorry. Expanded. Okay. Example I'll give you. PCl5. Okay. Now phosphorus is 16, I think. 1s2, 2s2, 2p6.
Sir, it's 15.
Thank you. 15. I could have immediately find from here also. This 3s2, 3p. No, no. 3s2, 3p1. 3p3 होगा तो 3p. Okay. Chlorine is 70. 1s2, 2s2, 2p6, 3s2, 3p5. These are the reactions. Okay. See here. We'll draw phosphorus a little bigger. And I'll put 5 laddus. Ink is almost finished. Okay. So can you see the circles? See here. Phosphorus. And here I'll put Cl, 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 and Cl. So phosphorus will give 1 electron each to 5 chlorine. It is 1, 2, 3, 4, 5. Chlorine 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now see here. This is 8. 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 Phosphorus is how much? Is it not 10? It's for 10. It's full of vision form. না আমি আজকে তো
অনেক তারিখ থেকে পারবে কি পারবে না ঠিক নাই না
না
কাজের প্রেশার আছে তো।
হ্যাঁ গ্রহণ আমি বুঝছি 20 মাসের লোড মোটামুটি হতো তাহলে কি সে সামনের বছর হইলে কোনো মধ্যে একটা ভালো মেয়ে হলে বিয়ে বাস তো মেয়েটা যদি ভালো হয় জীবন উন্নতি ওর বা যদি না হয় সংসার শেষ
Sir, done.
Okay, now next one you will do. I will not tell. I will only give right out on the electronic configuration. Okay. Please you do SF6. Sulfur is 16, so it will be 4, and fluorine is 9. So it is 2s2 2p5. So this is the valence electron, and this is the valence electron. Sulfur has 6 valence electrons, and fluorine has 6. Huh? So I'm only going to draw this one for you. Sulfur 1, 2, 3, 4, 5, and 6. Draw down. Put the valence electrons. Automatically the structure will come. And calculate the number of electrons. So for sulfur, how much it has come?
Sir, 12.
Yes. So both PCl5 and SF6 is important for your exam. Okay. Now we are going for the last one. It's called odd electron molecules. Odd means it will be unpaired. Okay, so let me take here NO. This is called nitric oxide. See here, nitrogen is 7. 1s2, 2s2, 2p3. Oxygen is 8. 1s2, 2s2, 2p4. So I draw. This is nitrogen, this is oxygen. Okay, dear? Now see here. In this case, nitrogen, let me draw. Nitrogen is 5. Oxygen is 6. See, oxygen is 8 and nitrogen is how many? See here, 7. Does it not have a odd electron? But this molecule is stable molecule. It has 7. Okay, so this is 1. These type of species are not too much. Okay, not so we'll go for nitrogen. NO2 is called nitrogen dioxide.
Sir,
Yes, please.
so in that nitrogens, there's 1, 2, 3, 4, 5, right?
Yes, 5. See here. So 2 plus 1 plus 5. See that
Okay, sir.
round.
So nitrogen is not getting octet, sir.
Yes. Though that is, it does not follow Lewis octet rule. Understood? These are
Okay,
the
sir.
all except. We are
Okay,
now
sir.
drawing all exceptions.
Okay,
Now
sir.
nitrogen dioxide. So nitrogen dioxide, what do you know? This is already there. So I'll write right now. This is nitrogen, this is oxygen, this is oxygen. Okay? See here, in this case, nitrogen. See. See here.
আকাশে যে একটু পিছলা হয়েছে কেন রোজ মুছে হয় তাও তো জানে
See. Here also you have odd electron. So this is 8. This is 8. This is 8. How much it is? It is 9. But it is even have an unpaired electron. Odd electron means unpaired electron. Okay. With this, I finish today's lecture.